Here we go. All right, so graphing equations of lines. So you see up here, up at the top, we have y equals mx plus b. So I'll make that a lot bigger here so we can look at it. So this is our standard equation for a line, right? This is a linear equation, and just like we have the quadratic equation, this is kind of even the step down from that. You probably spent a lot of time in Algebra 1 going over this. This is the standard equation of a line, all right? Where in our equation we have m, which stands for our slope, which is what we just spent last section talking about, right? And we have b, which is our y-intercept. And that's basically where your line hits the y-axis. X is your input. So if you remember when we were talking about our function terminology, X is your domain. And Y is your output. That's what you get out of the equation, and that is our range. Okay? So basically what we're going to do today is we are going to graph some equations, and we're going to look at just basically we're getting a feel for what they look like based off of the equations. So let's flip over to Desmos. It's on here somewhere. There we go. And this is pre-calc if you want to do some crazy polynomial functions. We'll get to do that soon. All right. So first up I have, let's graph the standard linear equation, which is y equals x. Oh, my window is wrong. So if you ever have something like this where you're graphing in Desmos or on a graphing calculator and you're like, that doesn't exactly look right, you might want to check your settings. So if you'll notice, my x-axis goes from -10 to +10, and my y-axis goes from like 100 to -50. So I'm going to go into my graph settings, which is this little handlebar here. I don't know if I can just, let's see, zoom square. I can do that. There we go. So it goes back to square, or you can type in values if you want it to be exact. You can do that in here. All right, so here is our standard linear equation, y equals x. This has a slope of 1, right? Because you would just imagine there's a 1 in front of this x. So if you rise 1, you run 1, right? Rise 1, run 1. And the y-intercept is at 0. There's no b here, right? The y-intercept is at 0. So that's why we hit right here at 0, 0. Everybody familiar with that? Yep. All right, cool. All right, so then what happens if we would graph y equals 3x? And I'm going to turn off the graph before I even graph it. So what happens if I graph y equals 3x? What would that look like? So as you're doing this, I want you to kind of, it's kind of on you to do this, but before you just type it in and look what it looks like, think, okay, could I graph this without a graphing calculator? All right, so y equals 3x tells me that my y-intercept, right, is still at 0 because there's no plus b. So my y-intercept is still at 0, right? Trying to let this draw on here for me. There we go. My y-intercept is at 0. My slope is 3 though. So if I know my y-intercept is here, my slope would be rise 3, run 1, right? Rise 3, run 1. Rise 3, or fall 3, rise -3, I guess, run -1. So without even popping it into my graphing calculator, I just want to make sure, can I graph it without a graphing calculator, just looking at the equation? So when I turn this back on, oh, it actually worked out nicely with the colors. I can see that my line goes through where I would anticipate the slope to be, right? All right, so now what if we graphed y equals x, let's turn this off, x plus 4. So let's see if we could graph that without our graphing calculator. So if you remember, our standard y equals mx plus b, right? Our slope is whatever is before x. So our slope is just 1. So it's going to have the same slope as this orange line. They'll be parallel to each other, right? Our y-intercept is at positive 4. So that means our y-intercept is going to be right here. And our slope is 1. So rise 1, run 1. Rise 1, run 1. Rise 1, run 1. All that good stuff, right? Rise -1, run -1. Rise -1, run -1. So then if I put up the graph for that, my line should go right through there. So what you'll notice about the black and the orange for Halloween is that they share the same slope, right? They both have a slope of 1, so the two lines are parallel to each other. Okay? So let's graph a couple other equations and see if we can anticipate what the graph will look like based off of what the equation is. Okay? Have you guys done this before, Connor and Sarah? Okay. Sarah, have you done this before? Awesome. All right. So then we'll just kind of go quickly through these. So we have y equals x minus 2. So if you have your paper there, just kind of, I think that one's pretty easy. We'll kind of skip over that one. Let's go to, what is the graph of, well, let's clear this off. What does the graph of x equals 4 looks like? For whatever reason, this always used to confuse me. So what does the graph of x equal 4 look like? So it doesn't matter what my y value is, right? X always equals 4. So when y equals 0, x equals 4. When y equals 1, x equals 4. When y equals 5, x equals 4. So if I wanted to graph x equals 4, it's actually just going to be a horizontal line through x equals 4. So then if I wanted to graph y equals 3, right? Y equals 3. We kind of have the opposite situation going on. It doesn't matter what x value is. When x is 0, y is 3. When x is 5, y is 3. When x is, 10, y is 3. Doesn't really matter what my x value is, if it'll let me put the point there. All right, so if I would graph y equals 3, we get a horizontal line goes through there. Okay, and this actually stays consistent with our equation y equals mx plus b because 3 is just our x-intercept. All right. Let's graph 2 more and then we will be done with this section. So there is a lot of problems in this section before I forget to tell you this. It's 3 through 54. That's a lot of problems. You do not have to make a graph for every single problem. So on my notes, I have like 4 or 5 different lines on every single graph. So what I would do is either get some graph paper or print out some coordinate plane graphs and just put, this is 3 through 13 are on this first graph, and then just label them as you go. So you can have multiple lines on one graph. I just wanted to mention that. And you are allowed to use your graphing calculator. I just want you to pick 3 of them to graph without a graphing calculator. So just kind of put a star by those. So really, this should be a very easy section. The reason that I have you doing so many is just so you can kind of, as you punch it in, kind of think in your head, okay, what do I think this is going to look like? Okay, that's what it looked like. I just want you to, it's kind of just getting a feel for what all these different ones look like. That makes sense? All right, so we had 2 more equations. Let's just see if we can graph them without a graphing calculator first, and then we'll double check our work. So I have y equals 3 over 2x minus 2. Okay, so when you're graphing without a graphing tool, we want to start with the y-intercept. Okay, so the y-intercept is going to be at -2. And that's because our standard equation is y equals mx plus b, and we have a -2 here. So I know that my y-intercept is going to be here at -2. Okay, and my slope is 3 over 2. So that means if I rise 3, I run 2, rise 3, run 2, rise 3, run 2. So then you can go in and check y equals 3 over 2 times x minus 2. Ta-da! It's always nice when it works out, right? All right, and then last problem. So I threw this in here. I don't think either of you guys are using a TI calculator, but I just wanted to mention this if you're using one for a test. So if I have 8y, sorry for the messy writing, minus 6x. Oh, you do have some ones here. Okay. So Sarah, if you are going to use your TI to graph this, okay, I don't have a TI website that I can use. But what you'll notice about a TI calculator, and this is just kind of good to know, is that you cannot, so Desmos kind of makes it a little easier, and that you can put a formula in this format into Desmos. When you go, Sarah, into your calculator and you go to graph up at the top, you'll see that the top left corner has a y equals button. All right, so that means that in order to graph any equation, it has to be in the format y equals something. Yes, exactly. You have, Sarah just wrote, it has to be y equals something. So basically what you have to do is you have to, manipulate your equation to make it a y equals equation, which you should know how to do based off of your algebra skills, but it's just good to practice. So that means that I have to get y by myself. So I'm going to change this equation to be 8y equals, and I'm going to add 6x to both sides. 6x minus 36. Okay. And then to get y by itself, I'm going to divide both sides by 8. All right. And I could do some fraction math, right? And I have 6x divided by 8 is the same as 3/4 x. And then 36 divided by 8 gives me 9/12. So if I wanted to graph this in with my TI calculator, this is how I would have to plug it in. All right. Now, if you ever have the situation where you have both, well, I'll show you that at the end because it'll kind of give away our graph. The other thing is if you're graphing without a graphing calculator, graphing by hand, this equation is not going to help you out, right? You have to have it in this format to know where your y-intercept is and your slope is. So our y-intercept is at -9 over 2, which is -4.5. Just about right here, right? And our slope is 3/4. So I rise 3, 1, 2, 3, and I run 4. Rise 3, 1, 2, 3, run 4. 1, 2, 3, 4. Okay. So now when I go to graph this, hopefully we did our points right? We have 8y minus 6x equals -36. Whew. And then I always like to double check that I did my math right. 3/4 x minus 9/12. So you'll see the orange and the purple line are in the same spot. All right, so fun with graphing, right? Woohoo! All right, so now we're going to move on to 2-4. Again, 2-3, I don't want that to be an overwhelming assignment. So seriously, if you want to just print off some graph paper and put a bunch of graphs on one graph, it's more about sitting there and seeing, okay, if I plug it in this way, what do I get? Okay, just getting a feel for how the different equations work. All right, so we learned about the graphs of linear equations, and in 2-4, we are going to learn how to write equations of lines. Okay, so this is if they give us some information, can we write an equation that satisfies our given data? Okay, so there's a little chart here at the top. It's not something you have to necessarily memorize. I think once you kind of really get the linear equation and the slope, you just kind of know what to do. But basically, if you're given the slope and the y-intercept, then it's really easy to write the equation of the line that goes through that slope and that y-intercept. If you're given the slope and 1 point, you can use something called a point-slope form of the equation to figure out what the equation is. And if you're given 2 points, we have to find the slope and then use the point-slope form. Now, I will say that I am guilty of not using the point-slope form. I just kind of like to plug in the data. So I'm going to give you both options when it comes to that, because for me, I always kind of forget the point-slope form, and I can remember the other way. That's just me personally. Now, the point-slope form works too. So we'll get there when we get there. Let's start with the easy peasy one, the one that we wish all of our problems were like, which is number 1. So let me pull this notes over here. Okay, so I'll make that bigger. Write an equation of a line that has a slope of -3/4 and a y-intercept of 7/2. So don't you wish all your homework problems were like this? So they tell you what the slope is, and they tell you what the y-intercept is, and they want you to write an equation. Well, we know the equation is y equals mx plus b. We know what the slope is, and we know what the b is. So voila, our equation is going to be y equals -3/4 x plus 7/2. Wouldn't it be awesome if all of our homework was like that? I would like it. Okay, so of course it's Algebra 2, so we have to get a little bit harder, right? So let's look at number 2 here. It says, write an equation of a line that passes through 4,2 and is parallel to and perpendicular to the line y equals 3x plus 1. Okay. So what we have here is we have the second scenario. We're given the slope basically, and we're given 1 point, and we want to be able to write an equation that represents this line. Okay. Let me erase some of this on here. My fancy eraser by hitting the back button. Okay. So like I said, I do it one way, the book does it another way, so I'm going to show you both ways. And we'll start up here. So first up, let's just take the easier case. We want a line that is parallel to y equals 3x minus 1. So what is the slope in y equals 3x minus 1? What is the slope of this circled equation? 3. Yep. You agree, Sarah? It's 3, right? It's whatever's before the x. So if we want to write an equation that's parallel, yeah. If we want to write an equation that is parallel, that means it has the same slope. So we know for part A that our slope is 3, okay? And we have 1 point that it goes through. We know it goes through 4, 2. All right, so now we're going to do it the book way. which I agree is easy, but I just always forget. So the book way is to use the point slope form, which is right here. So we say that y minus y sub 1 equals the slope times x minus x sub 1. Okay, and this y sub 1 and x sub 1 represent your your set of points that you have. All right, so we would say y minus, and y sub 1 would be 2, equals 3 times x minus 4, because that's our x sub 1. We just basically plug in our 2 points. And then we go to go do some algebra work. So we get y equals 3x minus 4 plus 2. I distribute my 3. I get 3x minus 12 plus 2, or y equals 3x minus 10. Okay, so that totally works. You get a nice equation. It's all pretty nice. I, for the life of me, can't remember this point, the point slope form. So I do it a little bit different way. Either way is completely fine. So I'm going to write my way over here in green. Okay, so we've established that we know the slope is 3 and that we have a point at 4, 2. So I know that the one thing I always remember is y equals mx plus b. That I can remember. Okay, I also know that my slope is 3. So I know my equation is y equals 3x plus b. And I'm trying to figure out what my b is, what my y-intercept is, right? I know that one point is at 4, 2. So if I plug in 4, 2 into my equation, I can solve for b. So I can say when y equals 2, x equals 4. Okay, so 2 equals 12 plus b, or negative 10 equals b. So when I put that all together, I plug my b back in, I get y equals 3x minus 10. So you see you end up with the same equation either way, right? 2 different ways to get there. I'm fine with you using either one. I tend to do the green one because I forget the point slope form, and I just know I plug in the slope and I plug in my point and I solve for b. But the point slope form works as well. Okay? Do either of you guys have a preferred method, or you don't do it enough to know which one you prefer? All right. Sarah said either one. Yep. So, yeah, either one works. So then part B of this is, let's do the same thing, but a perpendicular line. So this is kind of remembering one of those things. I don't remember when we learned it. Chapter 1, beginning of chapter 2. So if our slope is 3 for our line, right? I'm running out of space. I'll have to clear this off. Before we flip to perpendicular, let's go ahead and graph our original line and our new line that is parallel to it, just to double check that we actually did the right thing. So our original line was y equals 3x minus 1. Okay, and we said our new line is y equals 3x minus 10. So it's good that they are parallel, so that's good. And we said that our new line that we found should pass through 4, 2. So when x equals 4, I can get really close. There we go. When x equals 4, y equals 2. So we met that criteria, if I can talk right. So now we want to figure out a line that goes through 4, 2, but is perpendicular to our original line. So I think we're going to need some new paper for that, because I'm running out of space. Okay. So who remembers what a perpendicular line, if this slope is 3, maybe we didn't, did we talk about this in Algebra 2, or was that in pre-calc that I talked about it? I can't remember. My two classes are running together. Did we talk about a perpendicular slope? I feel like we just did. If we didn't, let's review it really fast. So two lines are parallel if they have the same slope. All right. So if they have the same slope, they're parallel to each other. I don't think we did talk about it in this class now that I'm thinking about it. Two lines are perpendicular to each other if the slopes have the negative reciprocal of each other. Okay. So two lines are parallel. Two parallel lines have the same slope. So the slope of the first line is equal to the slope of the second line. Okay. Two lines are perpendicular. Sorry for the crazy writing. They're perpendicular to each other if the slopes are the negative reciprocals of each other. So it's kind of weird. This is the sign for perpendicular. This is the definition. So two lines are perpendicular if they are if the slope of one is the negative reciprocal of the other. So in this particular case, our original line has a slope of 3. Okay. So the other line, in order to be perpendicular, has to be the negative reciprocal. So the slope of the other line has to be negative 1/3 in order for them to be perpendicular. So now we just go about the same way. We know that our perpendicular equation has to have a slope of negative 1/3 times x plus b. See, I'm defaulting to my way. You could also use the point slope form. All right. We also know that it goes through 4 too. So when y is 2, x is 4 plus b. So 2 equals negative 4/3 plus b. Ugh, fractions. Who likes fractions, right? Add 4/3 to both sides, so we basically have 2 plus 4/3 equals b. And if you do all the fraction work there, I end up with 10/3 equals b. Who likes fractions? Yuck. So I'm going to plug that back in, and my equation for my perpendicular line would be y equals negative 1/3 x plus 10/3. So then when I graph it, hopefully my line is perpendicular and it goes through 4 too. So let's switch over here. And one thing you'll notice with Algebra 2 is you're going to, everything, it never hurts to graph anything. Is my motto when it comes to Algebra 2. Like it never hurts to throw it in after you've solved it to see if your graph looks like what you would expect. So you can see the original line is in black, the new line is in blue. They appear to be perpendicular to each other. And the blue line also goes through the point at 4 too. Okay. So I think we did it. So how do you guys feel about that? Do you feel like we'd like to see another example, or feel like you can do it? Okay. And Sarah says she thinks she'll get it once you do it. Yep. I think it's one of those things. It's math, but I mean, it's just a lot of math. It's not necessarily hard. And hopefully you end up with ones without fractions. And sorry, I totally blanked because I just talked about the perpendicular line with the pre-calculus kids. So I forgot that I didn't explain it. So, all right. So one more example, and then I'll let you guys go on your way. What if, so this is our 3 cases, right? They give you the slope and y-intercept, easy peasy. We love those problems. They give you the slope in 1 point, and there's 2 different ways to do that. What if they just give you 2 different points? Could you write an equation given 2 different points? Well, you could, right? One way you could graph it and then figure out the slope graphically. That might be kind of fun. Fun math-wise, not fun, you know, just for fun. I'm going to graph this. Another way is to use all of our mathy tools here. All right, so we have an equation that passes through the point 6, 1 and -3, -8. So we have 2 points, and I do know we talked about this. We can find the slope of a line using 2 points because we talked about this back in 2.2, right? So that's basically the change in y over the change in x. And this is where I was telling you guys that sometimes I get a little confused and I have to label my points. So we know that we can find the slope if we have 2 points by doing the change in y. So I'm going to do 1 minus -8. That's my change in y, -8 in parentheses, over 6 minus -3. Okay. 1 minus a -8 would give me +9. And 6 minus a -3 would also give me +9. And so my slope is 1. Awesome. That's a nice, easy slope to deal with, right? So now I know that my equation is, well, I know it's y equals mx plus b. I know my slope is 1, so my equation now is y equals x plus b. Okay, and I have to figure out where my y-intercept is. So I can do that by picking one of my 2 points and just filling it in the equation. I'm going to pick 6, 1 because it's less likely that I have to deal with negative numbers. So when y equals 1, x equals 6 plus b. If I subtract 6 from both sides, I get -5 equals b. Now I go back to my original equation and I pull it all together and I get y equals x minus 5. Okay, so I say that this is my equation of a line that passes through 6, 1 and -3, -8. So then what I want to do is I want to pop back into my graphing tool. And Sarah, if you are graphing this on your TI calculator, you can put y equals x minus 5 on there. And if you want to see the points, you're going to use the button. There's a button up at the top called trace. And trace will actually jump onto your line and trace along the line, and along the bottom it'll say X and Y. Let me see if I can find trace on PI 84. Maybe there'll be a picture of it. It's always, let's see. Here we go. This is what it looks like. So this trace button, see how it's got the little square along your line? And it actually tells you this is the point where x equals 2.4 and y equals -1.2. And then you can use your arrows to move up and down. So that's how you do it on your calculator. So on Desmos, we had 1 point at 6, 1. Okay, 6, 1. That one worked. And then we have another point at -3, -8. So -3, -8. So we did a good job. Can pat ourselves on the back. All right, now if you guys wanted to be really geeky, let me have 3 minutes to be super geeky. We could one other way that we could have come up with our equation is we could have went old school and we could have plotted our points and used the graph to actually figure out our slope and our y-intercept. So what do I mean by that? Well, I knew my point was at 6, 1, right? That's a terrible point, but you get it. And we have another point at -3, -8 down here. Okay. So if I would, well, I don't know if I have a line tool to connect my dots. If I had a line, if I had a ruler on here, I'm trying to figure out if my toolbox has a little ruler that I can use. I have like the whiteboard feature on here, so I'm trying to figure out if I can draw a line. All right, I'm gonna have to freehand my line, so it's gonna be sad. Oh, maybe if I hit the shift button. Nope. I'm not just playing with tools here. Or let's see here. Clear that off. All right, -3, -8, 6, 1. All right, so the first thing that you could do is you could figure out your slope just by counting, right? So if I rise to go to my points, I rise 1, 2, 3, 4, 5, 6, 7, 8, 9, right? I rise 9 and I run 1, 2, 3, 4, 5, 6, 7, 8, 9. Just like when we figured out our slope, we got 9 over 9, right? So if I rise 3 and if I rise 9 and I run 9, that means my slope is 9 over 9 or 1. Okay. And then, so I've filled in my 1 right here in front of x, right? And then if I go to look at the y-intercept, I rise 1, run 1, rise 1, run 1, rise 1, run 1. So my y-intercept is right here at -5. So just based off of graphing the 2 points and using my slope, I could conclude that my equation is y equals, and then it's 1 times x, right? X plus a -5 or a -5. So then if I turn my graph back on, it goes through those points right there. So I think it's cool how it all comes together. I mean, cool for algebra, right? I would not necessarily recommend the graphing method as your first way to figure out the slope and y-intercept, because sometimes your y-intercepts aren't exactly at whole numbers, but it's just kind of good to know that they all come together. All right. That's all I have for you guys today. So you should be able to do 2, 3, and 2, 4 based off of that. Like I said, I don't want 2, 3 to be a big burden. So whatever is the easiest way to kind of get through all that, just, you know, whatever works for you works for me. So that's all I have for you guys today. Thanks for coming. All right, have a great rest of the day. And I'll see you guys on Monday. See ya.